So now I thought we'd do a quick step-by-step build of a red LED on a breadboard. This is a cheap breadboard, so I'm doing things to make a better connection. So we got the switcher. We're going to put it on the high side right there. That's the 5-volt supply. Those two top pins are always connected. Two bottom pins are always connected right there. Higher quality boards will squeeze this. They may go flying, so take that into account. Long lead, the anode of the LED. To the switch, short lead, the cathode's going to head towards where we got the negative supply. So I bent these pins purposely. These are cheap resistors right there. They don't make contact with they're thin wire. They're also cheap. And so therefore, I'm going to share a hole with the LED right there to make more contact. And kind of bend the metal in different ways. So hopefully they're making contact. We're protecting the LED from 5 volts, so it's a 220 ohm resistor. Kind of upside down, but doesn't matter what direction you put them. So you close the switch, LED lights up. Release the switch, LED turns back off. So now in this video, I thought we'd make a short video where I have a red LED circuit that is controlled by a push button switch on the low side of the circuit. So these snap into the board, okay right there. Bottom two are always connected, top two are always connected. Higher quality boards tend to pop these out. Be aware that it squeezes pretty good. So we got short lead, the cathode to the switch because that's on the low side, and then the long lead, the anode, up towards what's going to head towards the positive supply. These resistors that I bought from a kit are cheap. They got thinner leads than most resistors right there. So I'm going to share a spot with the LED anode right there. Hopefully I don't block your view there, but yeah, kind of got to wiggle in and bend the metal a bit so it makes a better contact. 220 ohms because we're using 5 volts. And there we go. So the LED is going to be off because I'm not pressing the button right there. The LED will turn on when I press the button and get a good connection. Release the button, it turns off. So now in this short, we're going to build a high side switch for an LED circuit right there. So connecting that, the top two pins are always connected, bottom two pins are always connected. These plug in pretty good into these cheap breadboards. The higher quality boards tend to pop them out. So we got the blue LED there, long lead, the anode. This is 5 volts by the way, positive side, and long lead anode, the switch, short lead, the cathode down a spot right there. This is a 1000 ohm resistor because we got 5 volts. That's going to power this, and blue LEDs don't need much current. They get pretty bright. These are cheap resistors, so I kind of bent the leads so they'll make better contact with metal, and I'm sharing a spot with the blue LED up there. So 1000 ohms to protect the blue LED from 5 volts. We should get, somewhere around about 2 milliamps of current. But there you can see LED is pretty bright when I close the switch. And open the switch, of course the LED turns off. So now in this video I thought we would quickly wire up a blue LED that is switched by a switch here that is on the low side of the circuit. So that's the negative side of the 5 volt power supply. And we're going to have the LED turn on and off. Those two are always connected. Those two are always connected. You press the button, it connects top to bottom. Long lead, the anode has to go towards more positive. Short lead has to go more negative. Since it's a blue LED, we're going to use a 1000 ohm resistor to limit current from 5 volts. So we'll end up with about 2 milliamps of current flowing when I press the button, but blue LEDs are still pretty bright at about 2 milliamps. I kind of bent the wire. Hopefully it's making extra contact in there. These cheap resistors that I bought are thinner lead right there. But in case I press the button, and LED will turn on once everything has a good connection and I get a good press. Release it, it turns off. Again, 1000 ohms protecting from 5 volts. So now I have that circuit up there where I have a blue LED that I can switch from the low side of the circuit. We're going to measure how much current will actually flow through this. And this breadboard is cheap. It doesn't make great connections, especially with these cheap resistors that have thinner leads than most resistors have. So we need to open the circuit to measure current. When the switch is not pressed, it is open. So we can just bridge that gap. And now we're shorting the current through the meter. And we have about 2 milliamps of current, which I actually expected. So we got a 5 volt power supply right there, 1000 ohm resistor. Blue LEDs dropping about 3 volts. So 2 volts across a 1000 ohm resistor. You can expect about 2 milliamps of current. So I kind of bent the wires and stuff of the LED, or the resistor. So hopefully it made better contact. And I'm sharing the slot with the anode of the blue LED so that it's touching more metal. And looks like I did okay. Make sure you turn the meter off, especially when you're measuring current. So now in this short video, I figured we would measure the current of this circuit here. So on a cheap board, so it doesn't make as good of connections, we have a red LED protected by 220 ohms from 5 volts. We have a switch though on the high side, and when the switch is open, we have an opening. So then we can close the opening through the meter right there. And see that we got about 13 milliamps of current, depending on how good of contact I make. So it's a cheap board. It doesn't make great contact. So yeah, we're actually doing okay. I'm going to turn the meter off now. You don't want to accidentally measure voltage when you have the meter set to measure current. So it's good to get it off there. But in case, yeah, there you can see we got the switch to the high side towards the positive. Got to close it. Now these are cheap resistors that I got. The leads are thinner. So they don't make contact very good. So I kind of bent them, and I'm sharing a row with the hole with the cathode of the red LED right there. So we got, okay connections there for making your first circuits.